My name is Josh McGinley. I work with Google Cloud Platform, and I spend a lot of time working with our clients and partners like Globant to implement machine learning pipelines. I want to talk today a little bit about patterns that I've seen in the market, what our clients are facing, and some pitfalls to avoid and how we can work around them. So when Google thinks about machine learning, there's really three main areas we think about to enable machine learning. There's capturing your data, doing something called feature engineering, which is tailoring your data to the machine learning model and then choosing your machine learning model. So Martin was mentioning earlier that there's a lot of churn in machine learning models. It tends to get a lot of attention because that's where a lot of the research is. There's always a new neural net or new type of way to do your machine learning. I guess what I'm here to talk about today is really about what we see driving success in machine learning pipelines isn't necessarily choosing the exact right model. It's more getting the right foundation in place so that you can feed your machine learning model and your AI application with the right data. So this is broadly the machine learning process that we see. You need to define your problem statement, define what you're trying to accomplish, what you're trying to predict. You need to spend a little bit of time capturing your data, choosing the right data that's going to feed into your machine learning model. You need to spend some time transforming it into a way that the machine learning model can understand. Finally, you train your model and you use it for predictions. Rarely do you ever go through this process once, start to finish, and it's all perfectly as you expected. With our most successful clients, it's almost always the case that they're doing this iteratively. They're spending a lot of time going through this process once, refining it, and revisiting the data that they're feeding into their model and tweaking it along the way. So what we've seen is many of our clients that struggle to implement machine learning and AI, perhaps they've started to collect their data. Many of our clients have started to collect their data on-premise. They might have like a large Hadoop cluster, for example, a large amount of data that they're managing on their own data center. Machine learning requires a very large amount of data. Requires a large amount of data to train and requires data to make predictions. So what we see is our clients often struggle with the data, managing the infrastructure that they're using to manage their data on-premise. As they scale up the amount of data that they're capturing, they often struggle with performance issues and just managing this infrastructure as the data grows. Often they need to hire specialized support staff to just keep the lights on with this data infrastructure. This can cause problems as you're not able to extract the value that you are expecting from capturing all this data. This also applies to data warehouses. We see many clients that have started to capture their data, maybe use it for regular analytics in their own data center. But then they struggle when they need to scale up the data warehouse to the speed and scale that's required for machine learning. It was mentioned earlier today that machine learning requires a lot of data, and that's really true. It's often more than is currently being captured as folks are using it for regular analytics purposes. So to summarize, scaling infrastructure, finding the talent to manage that infrastructure, and optimizing costs. These are all challenges that we see our clients regularly face. Just to scratch beneath the surface a little bit, data warehouses have a number of challenges that are unique to them. Often they have special licensing that require more money as you scale up the amount of data that you're processing. You need to maintain operations in your data warehouse, which can take a lot of time away from the value-add activities that you want your engineers spending time on. And oftentimes, it just simply can't scale to the amount of data required to make a successful machine learning pipeline. So this leads to higher upfront costs as you invest in managing this infrastructure. And it leads to a risk of failure of not being able to extract the insights that you'd really like from your data. So Google offers a number of managed data services where we own the operations. There's no operations for our clients to manage. It provides many of the key features that you'll require as you're looking to build a machine learning pipeline, but takes away the pain of managing the infrastructure. So you can enable real-time data and capturing the full scale of the data that you require by using managed data services from cloud providers, including Google. These systems have often been battle tested. At Google, we've been using BigQuery internally for years. And so we know that the scale is there for when our clients need it. So coming back to the machine learning process, the key insight here is that in order to make a machine learning pipeline successful, your engineers will need to spend a lot of time on iterating through this process, gathering the data that is going to feed into the machine learning model, and transforming it in a way that makes sense for machine learning. So I'll talk a little bit about feature engineering, which is the process of taking your raw data and translating it into an input into your machine learning model. So this is probably my most technical slide here, but I promise you that's it. So on the left here, we see our raw data, which is the type of data that many of our clients often have. And on the right is what a machine learning model will understand. Machine learning model is excellent at taking inputs of a bunch of numbers, but that's rarely the type of data that you have been storing already for your data warehouse. So there is a significant process to take this raw data, collect it, join it together with other data sets, and transform it into a type of data set that machine learning model can make use of. So this is called feature engineering. And really what we want in order to see our clients be successful is we want to see them spend more time looking at their data, analyzing it, trying to find the indicators that have predictive value from their data, and then feeding it into the machine learning model. We'd like to see them spending less time on managing their infrastructure. And our most successful clients with machine learning do exactly that. So another challenge our clients face is they may have a large amount of data, but they're not using it. Perhaps it's on backups or it's on tape, and it's not readily accessible to the key people in their organization that they need in order to do this feature engineering and analyze their data. So the most successful clients that we see, they take a holistic approach to enabling machine learning. They will look at their entire data pipeline from start to beginning, try to optimize for spending their organization's time on analyzing the data, usually by using managed cloud data services. That allows them to process data in real time, spend less time managing the infrastructure, and focus their organization on the most value-added activities. Google Cloud offers a variety of managed data services to help in your machine learning pipeline. We have managed solutions for processing the data, training your model, and even tooling to help you understand the machine learning model once you've built it. So finally, I think a key takeaway here is that there's a journey to enable machine learning. There's steps where you need to capture your data, organize it, and then analyze it in order to feed it into your machine learning model. Partnering with companies like Google and also Globant, who have been through this before, can be a key way to enable success in your machine learning pipeline. That's it. All right, thanks everyone.